A review of blockchain technologies. Abstract. In this paper we are going to go through blockchain technologies. No matter which blockchain you're developing on, blockchain engineers are in extreme demand. Protocols like Aave, Yearn Finance and Synthetix have huge sums of monetary value locked in them, allowing people to engage in decentralized finance, DeFi, which allows people to make censorship-resistant moves. Some of these protocols are less than a year old. Blockchain and solidity applications are building a world of more trust and accountability, with smart contract engineering skills becoming the most sought after in the world. Keywords: blockchain, technologies, decentralized, finance, solidity. Introduction. Bitcoin 15 was one of the first protocols to use blockchain technology. 16. The Bitcoin White Paper 15 was released by the pseudo-anonymous Satoshi Nakamoto. It outlined how Bitcoin could be used to make peer-to-peer transactions in a decentralized network. This network is secured by cryptography and allows people to engage in censorship-resistant finance in a decentralized manner. A few years later, in 2015, a man named Vitalik Buterin released a white paper 3 describing a new protocol called Ethereum, which used the same blockchain infrastructure but with an additional feature. Other co-founders took this blockchain technology and applied it in ways that people can make entirely decentralized applications for, decentralize organizations 12 and build smart contracts 14.5, and engage in agreements without a third-party intermediary or centralized governing force. Their idea was to take the same pieces that made Bitcoin and add smart contracts to it. Technically, this wasn't a new idea. In 1994, a man named Nick Szabo proposed a technology called smart contracts. A smart contract is a self-executing set of instructions. It is executed without a third-party intermediary. They are placed on a blockchain. Smart contracts are similar to regular traditional contracts that people make between each other, but instead of writing these contracts down on pen and paper or typing that on the computer, it's entirely written in code. The terms of the agreement are written in code and automatically executed by the decentralized blockchain network. Bitcoin also have smart contracts, however they're not Turing-complete. They don't have the full range of capabilities as a Turing-complete application like Ethereum. This is an intentional move by the Bitcoin developers, as they view the Bitcoin network as an asset, whereas Ethereum developers viewed the Ethereum network as an asset and also a utility for the building of smart contracts. Wayne Goodridge, Department of Computing and Information Technology, the University of the West Indies, Trinidad and Tobago. WI. This paper consists of 6 sections. In Section 2 we present smart contracts. Section 3 describes features of blockchain smart contracts. Section 4 gives details on the Ethereum wallet. In Section V we give 2 blockchain consensus mechanisms, proof of work and proof of stake. The conclusion is given in Section 6. 2 smart contracts. Smart contracts are revolutionary technologies, but they actually come with a fatal flaw. This is known as the Oracle problem. Blockchains are deterministic systems, and everything that happens in these smart contracts and on this blockchain happens in a little sandbox. If you want smart contracts to actually be digital superior agreements, then they need some way to interact with the real world and get real data which is external to or outside the blockchain computation. Oracles come into play in such circumstances. Oracles are devices that bring data into a blockchain or execute some type of external computation. At first view this seems like the perfect solution. Well, this may not quite be the case. Our blockchains and smart contracts are decentralized applications, and in order for them to stay decentralized, that means they would also need to get their data and external computation in a decentralized manner. Thus, your on-chain logic will be decentralized on the blockchain, but you'll also need your off-chain data and external computation decentralized as well. Combining these on-chain logic settlement layers and these off-chain data and external computation builds what's called hybrid smart contracts. A large majority of applications today are hybrid smart contracts. The protocol Chainlink 17 is a decentralized modular Oracle network that allows you to bring data into your smart contracts and do external computation. These hybrid smart contracts can have on-chain settlement and interact with the real world in some meaningful way. Chainlink is an incredibly powerful Oracle network because it allows us to get data, get randomness, do some type of upkeep or really customize our smart contracts and elevate them to perform other tasks. A hybrid smart contract is a smart contract with an off-chain component. A decentralized application is usually a combination of several smart contracts. Solidity is a smart contract programming language. You can write a singular smart with Solidity 6 and deploy on a blockchain such as Ethereum. Non-fungible token, NFTs, 8 and decentralized autonomous organizations, DAOs, 20 have taken the Ethereum vision to a new level. Once you learn the core basics of smart contract development on the Ethereum platform, the skills translate to these other chains as well. Learning a specific tool or chain is useful, because most of them work together pretty seamlessly. There are a few exceptions to this rule, and there are some smart contract platforms aka blockchains that don't use Solidity. However, learning the fundamental skills will translate to every single other blockchain, and Ethereum is by far the most popular and most used smart contract blockchain or smart contract protocol. These three terms are used interchangeably: blockchain, smart contract platform, smart contract protocol. Similarly, Chainlink is the most popular and powerful decentralized Oracle network and is going to be the one that we're going to focus on. Chainlink is also blockchain and smart contract platform agnostic, meaning it'll work on Ethereum, Avalanche 19, Polygon, Polkadot 9 or any blockchain or smart contract platform. This paragraph gives a quick summary of what was discussed so far. Bitcoin was the first application to take the blockchain technology into a meaningful concept. Bitcoin is like digital gold, where owners are able to make transactions between users. Ethereum takes this blockchain technology one step further. You can also build smart contract or decentralized applications, decentralized autonomous organizations and more. For example, you can code with smart contracts which can then access external data and external computation outside the blockchain using what's called oracles. Chainlink is the most powerful decentralized Oracle network and allows us to build hybrid smart contracts, which is a combination of decentralized on-chain logic settlement layer and any decentralized external off-chain data or computation hybrid smart contracts. A lot of questions can come up now, like what makes Bitcoin so interesting, or what makes it like a digital gold, and how are these smart contracts going to add any value to the real world? Before we get into the nitty-gritty of how these blockchains and how these smart contracts actually work from a low level, let's go high level and talk about some of the features and massive advantages that blockchains and smart contracts have over our traditional environments. 3 features of blockchain smart contracts. The first feature that these have is they are decentralized. It has a massive benefit. Blockchains are decentralized, meaning there's no centralized source that controls the blockchain. The individuals that make up blockchain are known as node operators, and they are the independent individuals running the software that connects the whole blockchain together. It's all these different independent individuals that make the blockchain decentralized. Let us look at an example. GameStop shares were no longer allowed to be bought because a centralized entity didn't want them to be bought anymore. They flipped a switch and nobody could buy that stock anymore. Essentially, having a single entity controlling the entire financial market with the power to make these choices for us can be dangerous. However, blockchain is here to solve this. There's a narrative called the bankless narrative, where users can actually live in a world where they don't have a bank. Banks, while good in their own right, have a history of doing some uncanny things. They also have the power to potentially freeze your funds, not letting you withdraw or move assets. They can do this as they are a centralized entity. They can flip a switch and control how you interact with your money every day. Being free of these centralized entities have this much power and this much control over your life has widespread positive ramifications: transparency and flexibility. Everything that's done on a blockchain and all the rules that are made can be seen by everyone. There's no backdoor deals and there's no shady happenings. Everything that happens on chain can be seen by you. This means that there's no special information that a few have. Everyone has to play by the same rules and everyone can see exactly what those rules are. Additionally, this doesn't mean that everything you do is tracked. The blockchain is pseudo-anonymous, so you can create different accounts and you can interact with it in many different ways. Speed and efficiency is another advantage. Have you ever tried to make a withdrawal from the bank and it took 3 to 5 days? All the bank is doing is adding and subtracting numbers, basic first-grade math. Why does it take so long? On the other hand, blockchains are verified by a decentralized collective. The settlement or withdrawal period in this case is substantially faster, and depending on the blockchain that you are using, it can be from 10 minutes all the way down to just a couple of seconds. In the stock trading or hedge fund world, it can actually take up to a week for you to buy or sell of a stock. You have to go through security and immutability. Blockchains are immutable, which means they can't be changed, and because of this it means that they can't be tampered with or corrupted in any way, shape or form. This allows us to have massive security on our data and on our transactions. If your computer goes down and your backup computers go down in the regular world, your data is gone. If all your data is on those two computers, you can be in dire straits. However, on a blockchain, if several nodes go down, it doesn't matter, because as long as one node and the entire system is running, the data is safe and secure. There are thousands or hundreds of thousands of nodes running these blockchain software, meaning that everything that happens is recorded and is immutable and won't change. Hacking the blockchain is nearly impossible and substantially harder than hacking a centralized entity. This is also much more secure in the asset sense as well. Instead of having gold in a vault or contract written on a piece of paper or on your computer, you have an asset that is locked on the blockchain forever. All you need to do to access it is have a private key or mnemonic, which is essentially a password, so you don't have to carry your gold around or carry your contracts around with you. It is always on the blockchain. Smart contracts in particular remove a massive conflict of interest in the traditional world. When we engage with users or individuals, they don't always have our best interests at heart. A lot of them are usually self-motivated in some sense. However, when we make an agreement with them, this agreement can have a massive conflict of interest with the user who's supposed to execute that agreement. Let's take insurance for example. If I pay an insurance provider $100 a month, and in the event that I get hit by a car, we've made an agreement or a contract that they're going to pay my medical bills. However, they have this massive conflict of interest. Insurance companies aren't in the business of giving out money. They're in the business of making money, so even though they've signed this agreement, when this event occurs, they still don't want to pay this money out to me, and if they can find a loophole in the contract, they will, because that is what they are motivated to do. This is native in the agreements that we make today. Another party is the one who decides whether or not they're going to execute their agreement, giving execution power to that party who may not want to execute the contract. This has often led to frustration. You can sue them and go through the court process, but now you are wasting all this time and money going through this long process to get something that you should have originally gotten in the first place. This leads us to one of the biggest value of smart contracts. Smart contracts allow us to engage in trustless and trust-minimized agreements. We currently live in a world of brand-based agreements. If I engage in some agreement and don't like the service that I'm provided with, my alternative to this is to go to another brand for an alternative service. The alternative brand is going to make the exact same set of promises to me, and then I have to trust them. Smart contracts allow us to move from this brand-based agreements to math-based agreements. These math-based agreements, we don't even have to trust that they're going to do the right thing. Hence, the name trustless, as 1 + 1 is always going to equal 2. In a math world, whatever the code determines is the input and output. That's exactly what's going to happen every single time. There is exact replication of state as in a Turing machine. Two major pieces of smart contracts are freedom and trustless. All these pieces allow us to live in a world that's more accountable, more trusting, more friendly. It allows us to work in an environment and a universe where things work seamlessly. It allows us the freedom to engage with other people. This happens because there's no centralized controlling body influencing every action that we make. All the rules are the same and nobody's getting special treatment. This brings out this new world of economic opportunity. As our lives become more and more digital, we're constantly being bombarded with centralized services that want us to use their interface so they can profit on how we interact and force us or push us to making the decisions that they're motivated for us. To make smart contracts, decentralized applications and blockchain allows us to be free of these parties and live in an environment that's truly free and trustless. Let's do a quick summary of what we just discussed. Blockchains are decentralized, meaning that they are not controlled by a single centralized entity, it is run by a network of independent users. Blockchains are transparent, meaning that everything that happens on a blockchain everybody else can see and everybody else can work with and see that everyone's playing by the same rules. Blockchains are quick and efficient, especially when it comes to monetary policy settlement. Blockchains are fast and easy. Immutability. Blockchains can't be changed or tampered with or corrupted and are incredibly secure. Smart contracts remove the massive conflict of interest traditional agreements. Smart contracts allow us to move away from political brand-based agreements to secure math-based agreements. Smart contracts allow us to engage in trustless and trust-minimized agreements. Smart contracts are a set of instructions which, when placed on a blockchain, are self-executing pieces of code not run by any centralized intermediary. In addition, smart contracts are typically paired with some type of oracle to get some information about the real world. When smart contracts are paired with an oracle, they're called hybrid smart contracts. Chainlink is a secure decentralized modular oracle network used to bring data into your smart contracts and also make some type of external computation. Decentralized autonomous organizations are organizations that live online and live in these smart contracts. They're similar to a regular organization in the traditional world, however they have people who maybe hold governance tokens to make voting decisions, or they do all their governance on chain, on this decentralized settlement layer, giving us the freedom to engage with each other as we please. For Ethereum wallet. Let's now get an Ethereum wallet and make our first transaction on a live blockchain. We're going to make our first interaction with the Ethereum blockchain. We're going to need an Ethereum wallet. We will use MetaMask because it's one of the most popular wallets and one of the easiest to use. We're going to download it. It works for Chrome, Firefox and many other browsers. It would be an extension in the top right hand of your browser. Thus, we can easily see at any time what we have in our wallet. This will store all of our Ethereum-based currencies. Hit Create Wallet, or if you already have a wallet you can actually import it. We will create our password and make sure that this is really secure. We're going to use fake money. If you lose access to your private keys, you will lose access to your wallet and you will lose access to all your funds. We're going to go ahead and hit confirm. We can use a tool like Etherscan1 to view different addresses. If you create multiple different accounts, each account has a unique identifier. The mnemonic, password, however, is associated with all accounts. If you lose your private key, you lose access to one account, but if you lose your mnemonic, you lose access to all your accounts. Back up your mnemonic since it has access to everything. In MetaMask 13 we can see Ethereum mainnet, and when we click it we actually see a bunch of other networks. When you buy Ether and when you work with Ether, you're working on the Ethereum mainnet. When you interact with smart contracts, you're also going to be working on the mainnet. However, may want to test our applications or do some type of integration tests. There are test nets 10 which are networks that resemble. They do not with real money, and it's just for testing your applications. Thus, a testnet blockchain is a blockchain where the currency doesn't have any real value but it resembles and acts exactly like another blockchain, for example the Ethereum mainnet. Etherscan is what's known as a block explorer. Block Explorers 21 are applications that allow us to see details of transactions that happen on a blockchain. When we work with smart contracts, we will also see them in a transaction in Etherscan. We see a unique transaction hash. This hash or this unique identifier uniquely identifies this transaction as the key of this transaction. If it is a successful transaction, you will see the block number. We have these transaction fees and gas price limits. Gas refers to the fee paid to node operators for successfully including a transaction in a blockchain. Anytime you want to change the state of blockchain, whether this is sending some Ethereum or making any type of transaction, you actually have to pay a little bit of Ether or a little bit of that native blockchain token to actually execute that transaction. Whenever we do something on the blockchain, it costs gas, and if we do something that would take a lot of energy for the blockchain to do, it will cost more gas. When I make a transaction, a node has to decide why they want to include my transaction into the block, and if there are a ton of people looking to make these transactions, then the nodes are going to be highly incentivized to pick the transactions that are going to give them a high price. The gas prices of Ethereum fluctuate with how much people use it, and the gas prices of all these blockchains fluctuate with how much people use it. You can view your transactions in MetaMask and Etherscan. V blockchain consensus. Bitcoin and Ethereum have thousands and thousands of nodes. Each blockchain keeps a full list of every transaction and interaction that happened on that blockchain. Blockchains have an immutability trait where nothing can be changed or corrupted. In essence, we can think of a blockchain as a decentralized database, and with Ethereum it has an extra additional feature where it also can do computation in a decentralized manner. Proof of work 7 and proof of stake 18 fall under this umbrella of consensus. Consensus is defined as the mechanism used to reach an agreement on the state or a single value on the blockchain. A consensus protocol in a blockchain or decentralized system can be broken down into two pieces: a chain selection algorithm and a civil resistance mechanism. The mining piece is part of the proof of work algorithm and is known as a civil resistance mechanism. Ethereum and Bitcoin currently use proof of work. Proof of work is known as a civil resistance mechanism because it defines a way to figure out who is the block author, which node is going to be the node, who did the work, and the author of that block. All the other nodes can verify that it's accurate. Civil resistance is a blockchain's ability to defend against users creating a large number of pseudo-anonymous identities to gain a disproportionately advantageous influence. It's basically a way for a blockchain to defend against somebody making a bunch of fake blockchains so that they can get more and more rewards. Two types of the civil resistance mechanisms are proof of work and proof of stake. Proof of work is silver resistant because a single node has to go through a very computationally expensive process called mining. No matter how many pseudo-anonymous accounts you make, each one still has to undergo this very computationally expensive activity of finding the answer to the proof of work problem or the proof of work riddle. The riddle can be as simple as finding an ounce, but each blockchain might change the riddle work or change the problem to be a little bit different. In fact, some of these blockchains make this riddle intentionally hard or intentionally easy to change what's called the block time. The block time is how long it takes between blocks being published, and it's proportional to how hard these algorithms are. These problems can change depending on how long they want the block time to be. If the system wants the block time to be very long, they just make the problem very hard. If they want to be very short, then the problem is made a lot easier. How do we know which blockchain is the real blockchain? Bitcoin and Ethereum both use a form of consensus called Nakamoto consensus. This is a combination of proof of work and the longest chain rule. The decentralized network decides that whichever blockchain has the longest chain or the most number of blocks on it is going to be the chain that they use. This makes a lot of sense because every additional block that a chain is behind, it's going to take more and more computation. If we see confirmations is set at 2, it means that the block that our transaction was in has 2 blocks ahead of it in the longest chain. Proof of work also tells us where these transaction fees and these block rewards go. Transaction needs gas to execute as a transaction fee. This transaction fee is going to the miners or the validators. In a proof of work network they're called miners, and in the proof of stake network they're called validators. All these nodes are competing against each other to find the answer to the blockchain riddle. It could be, for example, to find a hash that has 5 zeros at the start. Recall, depending on the blockchain implementation, that riddle is going to be a little bit different, but all the nodes are trying as many combinations as possible to try to get this answer first, as the first node to figure out the answer to the blockchain rule is going to get the transaction fee. When a node gets paid, they actually get paid in 2 different ways. One is going to be with a transaction fee and another piece is going to be the block reward. Thus, these nodes are competing against each other to be the first one to find this transaction, to be the first one to find the answer to this problem. They can be the ones to win both this block reward and your transaction fee. Some blockchains like Bitcoin, for example, have a set time when they are no longer going to give out block rewards and the miners or the nodes are only going to get paid from transaction fees. This gas fee again is paid by whoever initialized the transaction. Two types of attacks that can happen in these blockchain worlds. The first one being the Sybil attack 23. Sybil attacks occurs when a single node or a single entity tries to affect the decentrality of the network by pretending to be multiple different people. This simple attack is when a user creates a whole bunch of pseudo-anonymous accounts to try to influence a network. On Bitcoin and Ethereum this is really difficult because the user needs to do all this proof of work or have a ton of collateral in proof of stake. The other more prevalent attack is what's known as a 51% attack 22. We saw as part of our consensus protocol these blockchains are going to agree that the longest chain is the one that they're going to go with so long as it matches up with 51% of the rest of the network. This means that if you have the longest chain and you have more than 51% of the rest of the network, you can do what's called a fork in the network and bring the network onto your now longest chain. Thus, blockchains are very democratic. Whichever blockchain has the most buy-in and is the longest is the blockchain that the whole system is going to corroborate when nodes produce a new block and add to the longest chain. The other nodes will follow this longest chain that the rest of the network is agreeing with and add those blocks to their chain. Very small reorganizations are actually pretty common when a blockchain picks a block from a different longest chain, puts it on and then has to swap it out for another block and continue with a different blockchain. However, if a group of nodes had enough nodes or enough power, they could essentially be 51% of the network and influence the network in whatever direction that they wanted. The 51% attack has happened on blockchains like Ethereum Classic, which is not Ethereum. This is why the bigger a blockchain is, the more decentralized and the more secure it becomes. Proof of work is fantastic because it allows us to very easily protect against these civil attacks and keep our blockchains decentralized and secure. However, it has some drawbacks as well. Proof of work costs a lot of electricity because every single node is running as fast as they can to win this race to get the rewards. This has an environmental impact. Since proof of work and Nakamoto consensus, a lot of other protocols have taken this idea and gone in a different direction with a different civil resistance protocol. Many of them with the intention to be a lot more environmentally friendly, and the most popular one right now is proof of stake. There are some chains, Avalanche, Solana 2, Polygon, Polkadot and Terra 11, that are already using this proof of stake protocol and are live and thriving. Ethereum upgrade to ETH2 will use the proof of stake algorithm. Proof of stake is a different civil resistance mechanism. Instead of solving this difficult problem, proof of stake, nodes put up some collateral that indicate that they're going to behave honestly, aka their stake. In the example of Ethereum 2, nodes put up some Ethereum as a stake that they're going to behave honestly in the network. If they misbehave to the network, they are going to be slashed or have some of their stake removed. Obviously, this is a very good civil resistance mechanism because if you try to create a whole bunch of anonymous accounts, then each one of those accounts you have to put up some stake, and if you misbehave, you're going to run the risk of losing all the money that you put up as collateral. In this system, miners are called validators because they're no longer binding anything, they're actually just validating other nodes. Unlike proof of work, in which every node is racing to be the first one to find the block, in proof of stake, nodes are actually randomly chosen to propose the new block, and then the rest of the validators will validate if that node has proposed the block honestly. It's usually very easy for other nodes to verify if a proposal or a transaction is honest. A decentralized autonomous organization that collectively chooses the random number and collectively chooses which node is going to run next is utilized, keeping the blockchain deterministic. Proof of work is way less computationally expensive to figure out the new block because instead of every single node on the network trying to do this, only one node needs to do this and then the rest of the nodes just need to validate. It's usually considered a slightly less decentralized network due to the upfront staking costs to participate. However, the community can decide on the level of decentralization. The general consensus amongst blockchain engineers though is that proof of stake is very decentralized and secure. Another concept that's really important in these ecosystems is scalability. When we were talking about gas prices, we were saying that the gas prices can get really high if a lot of people want to send a transaction because a block only has so much block space and the nodes can only add so many nodes. Thus, when a lot of people want to use a blockchain, the gas price skyrockets. This is not very scalable because if we want to add more and more people to these blockchains, it's going to cost more and more to use the blockchains. More people are going to want to get into these blocks. This means that there's a ceiling to how many people can use the system because of the financial constraints that will get imposed as gas prices keep rising. Ethereum too is not only attacking the environmental impact of proof of work by switching to proof of stake, but they are also implementing this new methodology called sharding. Sharding is a solution to this scalability problem. A sharded blockchain means that it's going to be a blockchain of blockchains. There is a main chain that's going to coordinate everything amongst several chains that hook into this main chain. This means that there's more chains for people to make transactions on, effectively increasing the amount of block space. Sharding can greatly increase the number of transactions on a blockchain layer 1. Layer 1 refers to any base layer blockchain implementation. Bitcoin has a layer 1 as does Ethereum and Avalanche. A layer 2 is any application that is added on top of a layer 1. An example of layer 2 is Chainlink. A rollup is like a sharded chain. They derive their security from the base layer like Ethereum and they bulk send their transactions onto the layer 1. They solve some of the scalability issues by being another blockchain that people can make transactions. They're different from sidechains because sidechains derive their security from their own protocols while rollups derive their security from the base layer. 6. Conclusion. Ethereum and Bitcoin are currently both proof-of-work blockchains that follow Nakamoto consensus. However, Ethereum is moving to Ethereum 2, which will be a proof-of-stake sharded blockchain. Civil attacks are prevented due to protocols like proof-of-work and proof-of-stake. 51% attacks grow increasingly harder with the size of blockchain. Rollups are solutions to scalability issues. Implementations like Bitcoin or Ethereum have the scalability problem where there's not always enough block space for the amount of transactions that want. This leads to very high gas prices, and again, gas prices are how much it costs to interact with a blockchain. Authors and affiliations. Koffka Khan received the Master of Science, M.Philosophy, and Doctor of Philosophy degrees from the University of the West Indies. He is currently lecturer in computer science and has up-to-date, published numerous papers in journals and proceedings of international repute. His research areas are computational intelligence, routing protocols, wireless communications, information security, and adaptive streaming controllers. Wayne Goodridge is a lecturer in the Department of Computing and Information Technology, the University of the West Indies, St. Augustine. He did his PhD at Dalhousie University and his research interest includes computer communications and security.